Hi, this video is about bearings. What is a bearing? A bearing is an angle in degrees measured clockwise from the north. It is written as a 3-digit figure. For example, normally I would write 40 degrees as just 40, but as a bearing I would need to write it as 040. How do you solve problems with bearings? You use the sine and the cosine rule and solve just like you would for a normal triangle. Let's talk about the sine and the cosine rule. The sine rule is A over sine A, B over sine B, and C over sine C. The lowercase letters in the numerator represent the sides of the triangle, and the uppercase letter are the opposite angles from those sides. You use the sine rule in 2 different scenarios. The first case where you might use the sine rule is when you want to find a side, and you already have 3 angles and 1 other side. The second time is when you want to find an angle and you're given 2 sides and 1 other angle. The cosine rule is a squared is equal to b squared plus c squared minus 2bc times cosine a. The lowercase a, b, and c are all sides of the triangle, just like in the sine rule, and the uppercase A is the opposite angle from the side A. You also use the cosine rule in 2 scenarios, but these scenarios are different from when you use the sine rule. You use the cosine rule when you want to find a side and you already have 2 sides and the included angle between the 2 sides. You also use it when you want to find an angle and you already have 3 sides. Look at this diagram example. It's an example of a bearing. Here you have angle A, and you have it from the north, and you have it going clockwise. It's 65 degrees. So you would write angle A as 065, not just 65. The same for angle B. Clockwise, measured clockwise, it is 245 degrees. So the bearing of angle B is 245 degrees. Let's do an example problem.
Here's our example problem. A boat leaves the harbor and travels 9 kilometers northwest and then 12 kilometers north. We need to calculate its distance from the harbor and the bearing that it has to sail to now get back to the harbor. We're going to call this bearing angle Y. The very first thing that we do when we read this problem is sketch out the problem. It's very helpful in picturing what you need to find. Here, we can see that the harbor is here. We know that the boat goes 9 kilometers northwest. So it goes like this. Then it stops here. It says, no, I don't want to go this direction anymore. And then it starts going 12 kilometers north. We want to find the distance from where the boat is right now and the harbor. So we want to find this side of the triangle. We also want to find the bearing or angle that it has to sail to get back to the harbor. Remember, it's measured clockwise. So this angle right here, angle Y. In order to find out the distance from the boat to the harbor, we need to find this angle so that we can use the cosine rule. We can do this by we know that the boat is going northwest, which means that it's going halfway between north and halfway between west. That means it's at an angle of 45 degrees. Then when it switches and starts to go north, that's a 90-degree angle right there if you draw an imaginary line. Then you add the 45 and the 90 to get the total angle, this angle right here that we need in order to continue solving the problem. 90 plus 45 is equal to 135, as you probably knew. So this angle right here is 135. Now we have 2 sides and the included angle. And we want to find this side of the triangle. We want to find the distance. So, what rule do you think we're going to use? If you thought we were going to use the cosine rule, you're correct. Just as a reminder, the cosine rule is a squared is equal to b squared plus c squared minus 2bc times cosine a. A squared is the side that we're looking for. B is equal to 9. 9 squared is 81. C is equal to 12. 12 squared is 144. Negative 2 times 9 times 12 times the cosine of A is equal to negative 152.74. I used my calculator to do this before, but you can just use a scientific or graphing calculator and you'll get the same answers I did for this part of the problem. We know that the two negatives cancel out and become a positive. So the equation that we're left with is 81 plus 144 plus 152.74. Add all this together and you get 377.74. But a lot of people get confused here. They think, oh, we finished the problem, we solved what a squared is equal to. Remember, we're looking for a, not a squared. So we need to take the square root of 377.74. And I, again, did this with my calculator before, but it's 19.4 kilometers. So we've now solved the first part of the problem. We know that the distance from the harbor to the boat is 19.4 kilometers.
Hi, we just solved the first part of the problem. Now we have to solve the second part. When we were solving the first part, we figured out that the distance from the harbor to the boat is 19.4 kilometers using the cosine rule. Now, using that new information, we need to find the bearing that the boat needs to sail to get back to the harbor. In order to find this angle, angle y, which is the bearing that we're trying to find, we need to find angle x, which is the angle opposite from b. And then we need to subtract that from 180, because this is a straight line. So we can either use the sine or the cosine rule to find angle x. We have enough information to use both. But since we just used the cosine rule to solve the first part of the problem, let's use the sine rule. As a reminder, the formula for the sine rule is a over the sine of a equals b over the sine of b equals c over the sine of c. The lowercase letters in the numerator represent the sides of the triangle, and the uppercase letters in the denominator represent those opposite angles. So, first, to fill this part up, we know that side A is 19.4 kilometers from the last part of the problem. That's going to go in our numerator. And the denominator would be the sine of the opposite angle, which would be this one. So the sine of 135. Now, we're finding this angle. So that's going to be one of the denominators, but we don't know what it is. So we're just going to call it angle x. So the denominator is sine of angle x. The opposite side is side b. And that's equal to 9 kilometers. So that's going to go in our numerator. Now, in order to solve what for x, we need to cross multiply. I'm sure all of you are familiar with cross multiplying. So this shouldn't be too hard. First, we're going to multiply 19.4 times the sine of x. That's going to go on one side. And then 9 times the sine of 135 is going to go on the other side. Now, we want to isolate the sine of x so that we can solve for x. So let's divide both sides by 19.4. When you do that, on one side you get sine of x, and on the other side you get 9 times the sine of 135. And all of that divided by 19.4. Now, I solved this using my calculator. I have a graphing calculator app, but you can use a real graphing calculator or a scientific calculator too. When I solved that, I got that the sine of x is equal to 0.328. Now, we need to isolate x. So we need to do the inverse function in order to isolate the x. So the inverse function of sine is sine to the negative first power, and that times 0.328. I did this in the calculator as well. And when I did that, I got 19.14. In this problem, we can round it to the 10th. So angle x is equal to 19.1. But remember, no, we're not done yet. We need to find the measure of angle y. So far, we've only found angle x. We've done most of the work, but we have one more step just to get to the answer. We're going to do 180 minus 19.1, which is the measure of angle x. and you get 159.9 when you do that. So the bearing to get back to the harbor that the ship needs to turn is 159.9 degrees, or you could round that up to 160 degrees. As a review, we used the cosine rule to figure out the distance from the harbor to the boat, and we figured out that that was 19.4 kilometers. And the bearing that the ship needs to sail to get back to the harbor, we used the sine rule, and we figured that that is 159.9 degrees or 160 degrees.